Okay, in this video I'm going to explain to you the formation of an erosional depositional feature in river landscapes, and I'm going to focus on the V-shaped valley. In terms of exam questions, just as with the other features, you have to first pay attention to the question itself. Does the question tell you that you may wish to use an annotated diagram, or does it say explain with the aid of a diagram or diagrams? Now, that might seem like a subtle difference, but it's quite important to pay attention to it, because if it says you may, what you're allowed to do in that situation is not draw a diagram at all and just write out an answer. In this version of the question, if it says with the aid of a diagram, then it does expect some kind of diagram. Now, just like with all the features, your diagram can be really simple. And if you actually look at page 53 of your class textbook, you'll see a nice little sequence of very simple diagrams that will help you do this. Or you could simply go with drawing a V in the landscape with a river at the bottom and just a label saying V-shaped valley, and maybe include vertical erosion on your diagram. And you won't get any marks for that in itself, but that will tick the box of having drawn a diagram, and then you can write the answer. If you want to have a fully detailed answer that includes a diagram and some writing, do have a look at page 53. It's a great answer, and the only thing I would add to the answer that's written on page 53 is that you explain what hydraulic action, abrasion, and solution are, because on page 53 they are named, but they're not given in much detail. And obviously you can pick up marks by unpacking what hydraulic action, abrasion, and solution actually mean and what those terms are. Right, let's have a little look at how a V-shaped river valley is actually formed. So we need to start, we use this diagram because it's a nice little and simple way of doing it and explaining it. You're going to want to make sure you have your three: hydraulic action, abrasion, and this one down here, solution. I know they also call it corrosion, but solution's the one you probably want to refer to. Be ready to use them in your answer and explain exactly what they are, and that will pick up lots of marks. You'll pick up about half of your marks if you can name these and describe actually how they work. So, first part of your answer is to explain that in the mountains, when a river flows across a steep gradient, so that's the first mark, it's more likely to have a high level of vertical erosion as the river is trying to eat down into the landscape to get to sea level, and that will be your second mark. There'll be relatively low amounts of lateral erosion at this point. Because of the high amount of vertical erosion, the river channel, or the river, will start to eat downwards into the landscape. And if you look at page 53 of your class textbook, you'll see diagram 2 shows a nice vertical wedge being created. Now, as it eats down, a couple of things are happening. First of all, because of abrasion and hydraulic action and solution, the riverbanks are being undercut. So here and here, you'd have undercutting happening. And that causes the banks to collapse and the water to then wash away that material. And that's what's causing the river to get deeper and deeper. Now, as soon as you mention hydraulic action, abrasion, and solution, you then want to tell me what they mean. And what I would suggest you do is just pause the screen now and have a look at what they mean here. So you have a nice description of these three types of erosion. Now, hydraulic action, abrasion, and solution are causing the river to eat downwards into the landscape. But what gives the actual valley its V-shaped is to do with other processes on the side that are out with the control of the river itself. Now, as we can see in diagram 2, heavy rain in the mountains will cause a lot of water to be flowing down the mountain sides into the river. And as this water flows, it's going to mix with the soil. And the soil is going to become very heavy and waterlogged, and will start to slump, or slip as it's called, down the slope. And as that mud just gradually slips over the years, as soon as it gets to the river water will then wash it away. So the actual physical sides of the valleys are slipping down the slope towards the river because they're saturated with water. Another process that's going to be happening is weathering, where high up in the mountains, cracks in rocks will get water in them, and then at night, especially in winter, the water will freeze and expand, and eventually those cracks will shatter in a process known as freeze-thaw, and you'll be familiar with that from the glaciation topics. And these rocks will then break off because of freeze-thaw and roll down the mountain into the river. And as those additional rocks enter the river channel, that will also increase the rate of erosion on the bottom of the river, especially through the process of abrasion, which is where rocks are moved by the water and erode the base of the river as they collide with the base. So that material getting added through freeze-thaw into the river also accelerates vertical erosion downwards. Over time, your valley sides will get steeper and steeper due to this slumping and the weathering of freeze-thaw. So key to this answer is in the mountains on a steep gradient, lots of vertical erosion, channel eating downwards, undercutting of the riverbanks because of hydraulic action, abrasion, and solution, which you also then tell me what those three words mean. On top of that, the valley sides start to get steeper and more V-shaped due to slumping. Tell me why slumping occurs, because the water falling in the mountains saturates the soil and the soil becomes heavy and just slips down the slope. And also freeze-thaw, explain what freeze-thaw is and how that then leads to rocks breaking off and creating this more V-shaped valley. Okay. Once again, I would recommend if you want a kind of sequence diagram approach, either look at your class notes or go with a much simpler version that you can see on page 53 of the textbook.